Assalamualaikum guys. So today I would like to talk about thermochemistry. First of all, we need to know what is thermochemistry. Thermochemistry can be defined as the study of the change in thermal energy during a chemical reaction. And for your information, thermochemistry is divided into two, which is exothermic and endothermic. Now, we need to know what is exothermic. Exothermic are chemical reactions that release heat into the environment and making the ambient temperature increase. Meanwhile, for endothermic are chemical reactions that absorb heat from the environment and making ambient temperature decrease. As you can see, this is the difference between exothermic and endothermic. The example of exothermic are respiration, neutralization, and combustion reaction. For the example of endothermic are dissolution of ammonium salt in water, photosynthesis, and decomposition of metal carbonate when heated. Now, let's continue with reaction heat. Reaction heat is the change in thermal energy when 1 mole of the substance reacts or 1 mole of the reaction product form a material. Reaction heat divided into 4. Heat of precipitation, heat of displacement, heat of combustion, and heat of neutralization.
The first one is we're going to talk about heat of precipitation. So what is the meaning of heat of precipitation? The meaning is the heat changes when 1 mole of precipitate is formed from ion. Double decomposition occurs in heat of precipitation. This reaction will produce insoluble salt and soluble salt. Next, we must find the number of mole lead nitrate using the formula N equal mV over 1000. M is the molarity of solution while V is the volume of solution. From the question, we know that the molarity of lead nitrate is 1.0 mol Tm minus 3 and the volume of lead nitrate is 100 cm cube. So we just insert the number to the formula and got the answer is N equal 0.1 mol. So it's the same goes with the sodium sulfate. We got the same answer which is N equals 0.1 mol. Next step, calculate the heat change. First, we must find the mass of solution which is M equal total volume of mixture times density of solution. So, the volume of mixture of each solution is 100 and it's given the density of solution is 1 gram cm minus 3. So we got the answer M equal 200 gram. After that, we calculate the change of temperature. From the question, 33.0 degrees Celsius minus 30.0 degrees Celsius, we got the answer 3.0 degrees Celsius. After we got the mass and the change of temperature, we can use the formula Q equal mc theta to find the heat release in this reaction. So, after calculate, we got the heat release in this reaction is 2520 joule, and convert it to kilojoule, we got 2.52 kilojoule. Last step, calculate the heat change for the formation of 1 mole of precipitate. Using the formula delta H equal heat of change over number of mole precipitate formed, we can know the heat precipitation of lead sulfate. So 2.52 kilojoule over 0.1 mole, we got the answer 25.2 kilojoule mole negative 1. So the final answer we got heat of precipitation of lead sulfate is negative 25.2 kilojoule mole minus 1. The negative sign show that this is an exothermic reaction. Next, heat of displacement. What is the meaning of heat displacement? The heat change when 1 mole of metal is displaced from its salt solution by a more electropositive metal. This is the example question of heat of displacement. So the question is asked, the heat of displacement of ion from its salt solution. As usual, the first step is we must write the chemical equation. Magnesium react with iron sulfate, produce iron and magnesium sulfate. Step 2. Calculate the number of mole of iron sulfate solution using the formula N equal mv over 1000. From the question, we know the molarity of iron sulfate is 0.25 mole dm minus 3 and the volume of the iron sulfate is 50 centimeter cube. So the 50 times 0.25 over 1000, we got the answer N equals 0.0125 mole. Step 3. Calculate the heat change. First, the mass of solution M equal the volume of iron sulfate times the density of solution. So M equal 50 centimeter cube times 1 gram centimeter minus 3. The answer is 50 gram. Next, calculate the heat change using formula Q equal mc theta. M is the mass of solution, C is the specific heat capacity of solution, theta is the temperature. Insert all the number to the formula and we got 840 joule, and convert it to kilojoule, we got 0.84. Last step, calculate the heat change for 1 mole of ion displaced using the formula delta H equal heat change over number of mole to find the heat of displacement of ion. So 0.840 kilojoule over 0.0125, we got the answer 67.2 kilojoule. The final answer is negative 67.2 kilojoule mole minus 1. The negative sign is show this is an exothermic reaction.
Hi, my name is Udawisha and now I would like to talk about heat of neutralization. Neutralization is a reaction between an acid and an alkali to produce only salt and water. Neutralization is basically an exothermic reaction. Hydrogen ion H plus from acid reacts with hydroxide ions OH minus from alkali to form water, which is H2O. Now we are looking at the heat of neutralization. So now this slide is talk about neutralization reactions can occur between acids and alkalis of different strength as follows. First, we can see strong acid and strong alkali, weak acid and strong alkali, strong acid and weak alkali, also weak acid and weak alkali. Weak acid or weak alkali ionize partially in water and some remains as molecules. Some of the heat released during neutralization is absorbed and used to completely ionize the weak acid or weak alkali in water. Therefore, the heat release is lower. So, this slide shows how to calculate the heat of neutralization. So now I would like to talk about heat of combustion. The definition of this subtopic is the heat when 1 mole of a substance is completely burned in excess oxygen, O2. Each substance releases different heat of combustion. As you can see, This figure shows a graph of heat of combustion of alcohol against the number of carbon atoms per molecule of alcohol. The discovery of how to light a fire considered as one of the most important discoveries in human civilization. Energy generated through combustion allows humans to chase away wild animals, cook food, and control their own light sources and heat. Knowledge of exothermic and endothermic reactions enables human life to be more comfortable. For example, you can learn the use of cold pack and hot pack. The examples of applications of exothermic reactions in everyday life, such as hot can, thermite reaction, and combustion fuel. Okay, so these are examples of applications of endothermic reactions in everyday life, such as gel pack, self-cooling beverage, and sorbet. So, this is the formula for fuel value, which is heat combustion of substance divided by molar mass of substance. So this slide shows example of calculation how to find a fuel value. This slide shows example. So now I would like to talk about factors influencing the choice of fuel. One of the factors is fuel value. High fuel value indicates greater energy efficiency. Availability and sources. The ease of sourcing the fuel locally affects its usage. Cost of fuel. Economic viability plays a key role, especially in large-scale applications. Environment effects. Some fuel, like hydrogens, produce fewer pollutants, while others, like wood and petrol, can contribute to greenhouse gas emissions and soot production.